we have used this theorem, limit x tends to a fx by gx is equal to limit x tends to a fx divided by limit x tends to a gx. Remember that you must mention this on the right side of this step. We have cancelled x minus 1. Now, as discussed earlier, we first put the value x equal to 2 in both numerator and denominator. 4 minus 4, that is equal to 0. Now, if I put x equal to 2 here, it will be 6 minus 2, that is root 4, 2, and this is 2 plus 2, 4, root 2, root over 4, that is equal to 2, that means denominator is also 0. Friends, welcome to my btosacademy, welcome to my maths class. Today I am continuing the topic limits. Already in the last class I have discussed theoretical parts of limits, definition, fundamental theorems, also standard limits. Today I shall first work out sums. Already I have written down on the board. First of all, let me discuss the steps to be followed or working rules of finding values of given limits. First of all, you first put the value a when x tends to a in the given expression. If I call the given expression as fx and check whether we get a definite value, of course finite value. If we get that value, then that will be the limiting value of the given function fx. If we see that fx is of the quiescent form, then we put the value at the numerator and at the denominator. Now, if we see either numerator or denominator, especially denominator vanishes, then the step to be followed, first we resolve into factors both the numerator and denominator and cancel the common factor. Generally, x minus a will be the common factor as x tends to a. Actually, if we put x equal to a at the numerator and denominator, we will find that both will be 0. So that for finding the limiting value, we first cancel those common factors from the numerator and denominator as x tends to a. Hence, x is not equal to a, therefore we can cancel from numerator and denominator and follow the standard limits. Now, let us start. Already I have written down few sums. After writing down the limit, first let us try to recall the standard limit to be used here. We find x to the power 5 minus 32 at the numerator. Now 32 can be written as 2 to the power 5. That means x to the power n minus a to the power n form. Therefore, in this case, we have to use the standard limit. Limit x tends to a, x to the power n minus a to the power n by x minus a is equal to n a to the power n minus 1. This standard limit is to be used here, but at the denominator is also of the form x to the power n minus 8 means 2 cube, that means x to the power m minus a to the power n. To get the standard form, we first divide the numerator and denominator by x minus 2. Here we find x tends to 2. Limit at the starting I mentioned that first we put the limiting value of the independent variable. Here x tends to 2, that means 2 is the limiting value for x. We first put that value in the expression and we find this is 2 to the power 5 minus 32, that means 0. 2 cube minus 8 means 0, that means both numerator denominator vanish if we put x equal to 2. That means we have to think different method. The method is here, since the numerator and denominator both are in the form x to the power n minus a to the power n, we have to use here the standard limit x tends to a, x to the power n minus a to the power n by x minus a. For that I have divided the numerator and denominator by x minus 2. I have got this form. Now here we have used the theorem here we have used this theorem. Limit x tends to a fx by gx is equal to limit x tends to a fx divided by limit x tends to a gx. Here limit x tends to a gx is non-zero. Now at the numerator and denominator we are getting standard form, standard limit this one. We put that. After calculation, we get the result 20 by 3. Now, the students will see we can also evaluate this limit by resolving into factors the numerator and denominator. After checking that both numerator and denominator vanish for x equal to 2, we can resolve into factors. But when the highest power of the variable will be large, in that case resolving into factors will be time taking. That is why we use the standard limit here. Thus, following these steps, we have got the limiting value of the given sum 20 by 3. Now, I move to the second one, number 2. Limit x tends to 1, x square minus 4x plus 3 divided by x minus 1. First of all, we check if I put x equal to 1 at the numerator and denominator, then we find both will vanish. That means x minus 1 is a common factor of both the numerator and denominator. For that, we first resolve into factors the numerator. Now, x square minus 4x plus 3, that is equal to x square minus 3x minus x plus 3 is equal to x into x minus 3 minus 1 x minus 3 is equal to x minus 3 x minus 1. Therefore, given limit is equal to limit x tends to 1. Now, numerator is x minus 3, x minus 1, denominator x minus 1. Now, we cancel x minus 1, keeping in mind that x is not equal to 0. Here x tends to 1 and that matter is to be mentioned here. Since x is not equal to 1 as x tends to 1. Remember that you must mention this on the right side of this step. We have cancelled x minus 1. Now, limit x tends to 1, x minus 3, we put the value. Finally, we have to put the value, limiting value of the independent variable, that is x equal to 1. That is the answer. Now, I move to number 3, limit x tends to 0 root over 1 plus x minus root over 1 minus x divided by x. Now, the first step is I put the value x equal to 0 in both numerator and denominator. We find both vanish. Therefore, we have to think other method. What will be the other method? Here we see the numerator is in irrational form. Irrational form. In this case, we have to rationalize the numerator. One thing, if you find denominator is in the irrational form, then you have to rationalize the denominator also. Here it is in the form x, therefore we need not rationalize that. That is apparently in rational form. Now, we do the next step, limit x tends to 0. Here the rationalizing factor will be root over 1 plus x plus root over 1 minus x. Root over 1 plus x minus root over 1 minus x into root over 1 plus x plus root over 1 minus x divided by x into root over 1 plus x plus root over 1 minus x. that will be equal to limit x tends to 0, and here the product will be 1 plus x minus 1 minus x, and the denominator is limit x tends to 0. After simplification, numerator will be 2x, x within bracket 1 plus x plus root over 1 minus x. Now these x's will be cancelled, as since x is not equal to 0, as x tends to 0. Now finally we put x equal to 0, then it will be 2, 1 plus 1, that is 1. Students, learners, you must note this while you are cancelling by multiplication division method, then you must mention this one, very important. Thus finally we get the result limiting value 1. Next I move to sum number 4. Limit x tends to 2, numerator is x square minus 4, denominator root over 3x minus 2 minus root over x plus 2. As discussed earlier, we first put the value x equal to 2 in both numerator and denominator. 4 minus 4, that is equal to 0. Now if I put x equal to 2 here, it will be 6 minus 2, that is root 4, 2, and this is 2 plus 2, 4 root 2, root over 4, that is equal to 2, that means denominator is also 0. Therefore, and also we find the denominator is in irrational form. Therefore, we have to rationalize that. Therefore, the next step will be limit x tends to 2. I first resolve this one, x plus 2 into x minus 2, then rationalize the denominator. That means we have to multiply the numerator by 3x minus 2 plus root over x plus 2, and if we multiply the denominator by this expression, then the product, I am writing down directly the product, 3x minus 2 minus x plus 2. Now limit x tends to 2, x plus 2, x minus 2, root over 3x minus 2 plus root over x plus 2. Now if we simplify, we see that the result will be here 2x minus 4. That means we can take 2 common factor, 3x minus x, 2x, minus 2 minus 2 minus 4. I take 2 common factor and get this one. Then we find that x minus 2 is a factor of numerator and denominator. Both we can cancel as x tends to 2. Since x is not equal to 2, as x tends to 2. Now finally we put the value x equal to 2 in the simplified form of the expression, then this is 2 plus 2 into this is 2 and this one is also 2. Thus finally 4 into 4 whole by 2, the result is 8. Thus limiting value is 8.